You're standing still right now. At least, that is what the floor tells you. But near the equator, you, the building, the road, and the ocean are already moving east at about 1,040 miles per hour. Now, imagine the solid Earth stops spinning for exactly 5 seconds. The ground stops. You do not. Before we press the button, one honest rule. No real force could stop a planet instantly without the breaking itself becoming the disaster. So our imaginary switch keeps the solid Earth intact and quietly removes its rotation. The atmosphere, oceans, aircraft, satellites, vehicles, loose objects, and people keep the motion they already had. 5 seconds later, the ground instantly resumes its old speed. That means this story has 2 impacts, not 1. At 0 seconds, inertia takes over. On the equator, anything not firmly anchored still has an eastward speed of about 465 meters per second. That is roughly Mach 1.4. In 5 unobstructed seconds, an object would travel more than 2 kilometers. But almost nothing gets an unobstructed path. People meet walls. Cars meet barriers. Furniture crosses rooms. The ground has not thrown you west. It has stopped beneath you while your body keeps going east. Latitude decides how violent the first moment is. At 30 degrees north or south, the retained speed is about 1,450 kilometers per hour. At 45 degrees, it is about 1,180. At 60 degrees, about 837. At the exact poles, rotational surface speed is nearly 0. So this is not an equal global blast. Tropical regions take the hardest direct hit. Mid-latitudes still face extreme motion, and the polar interior gets a brief but very dangerous head start. Then the air arrives. The atmosphere was rotating with the planet, so it keeps moving east while the surface stops. Near the equator, the relative wind is supersonic. This is not technically a planet-wide hurricane. Hurricanes are rotating weather systems. It is closer to the ground, suddenly appearing inside a moving atmosphere. Pressure shocks break windows. High-speed debris becomes the greatest hazard. Towers and bridges remain attached to the stopped ground, but they were never designed for air rushing past at jet speed. The ocean follows the same rule, with much more mass. Water keeps its eastward momentum and runs into coastlines, continental shelves, islands, and the eastern walls of ocean basins. Do not picture one perfect wave wrapping around Earth. Real coastlines are too complicated. Some water surges into ports and river mouths. Some piles against land. Some is redirected into violent currents. Near the equator, the water's inherited motion corresponds to more than 2 kilometers in 5 seconds, if nothing blocked it. Land blocks it quickly. At sea, ships initially move with the water beneath them, but harbors become traps. On land, ports, refineries, coastal power stations, and undersea cable landing sites face the combined impact of water, debris, and collapsing infrastructure. A conventional tsunami begins with a large displacement of the sea. This is different. An entire rotating ocean has suddenly lost the moving boundary beneath it. The result would vary wildly by basin, depth, and coastline, so any single global wave height would be bluffing. Aircraft are a strange exception. A plane cruising in the atmosphere keeps moving with that air mass, so it is not instantly hit by the full relative wind. But the runway, control tower, navigation reference, and city below have stopped. Airports near the equator slide more than 2 kilometers behind their expected rotating position during the pause. Pilots may remain airborne, but the world they need for landing is being torn apart. What about space? Satellites do not suddenly fall. Orbit is controlled mainly by gravity and orbital momentum, and neither disappears. GPS satellites continue circling Earth. The International Space Station continues falling around the planet exactly as before. Geostationary satellites are different only from the ground's point of view. They keep moving while Earth pauses, so they're no longer perfectly fixed above one longitude. 5 seconds creates a small offset, not a rain of spacecraft. Now the clock reaches 5. The solid Earth restarts eastward at its old speed. This is the second impact. During the pause, air and water have crashed into terrain and lost some of their original motion. Loose objects have struck the ground. Buildings are already damaged. Then the surface accelerates beneath everything again. Material slowed by the first collision is hit from the opposite relative direction. Some structures that survived the stop fail during the restart. Here is what has not happened. Gravity does not switch off. At the equator, removing the small centrifugal effect would make you weigh only about 1/3 of 1% more. Earth does not leave its orbit around the sun. The moon does not fly away. The oceans do not escape to space. Their inherited speed is nowhere near Earth's escape velocity. And 5 seconds without the Coriolis effect is too short to redesign the climate. The immediate danger is momentum, not a frozen day or a broken solar system. Afterward, the planet is spinning normally again, but civilization is not. Damage is worst in low latitudes and along vulnerable coasts. Power grids lose substations and transmission corridors. Ports and fuel networks fail together. Fires burn without reliable water pressure. Communications survive unevenly because satellites remain overhead while ground stations lose power. Polar regions may preserve more intact infrastructure, but they still depend on a global system that has just been cut apart. Would humanity disappear? That claim goes too far. Geography matters, construction matters, and our magical stop hides physics that no real model can reproduce cleanly. But this would be a global catastrophe, not a dramatic 5-second pause followed by normal life. The lesson is simple. Earth's rotation feels invisible only because nearly everything around you shares it. Remove the floor from that agreement, even for 5 seconds, and standing still becomes the most dangerous speed on Earth.